Okay, so the next set of slides will talk about, some best practices we recommend and some tuning on our Aurora. So there are a lot of things that you saw, that are not set, and you will see that are not set by default. And the reason is, Aurora is a very big system compared to small systems that we use for testing, or small systems that are used on other production site like LRZ, and the smaller cloud environments and things like that. So we'll try to make a lot of what I'm talking about here default in some cases, but I just want to give a preface. This is stuff that we've discovered through our testing throughout the last year and so, last few years, and of course, this will evolve also over time as we get more application and more usage on Aurora. So the documentation on our side and on the LCF side will be updated to reflect that. And you can see, like today, some of the best practices and recommendation I do not match the current ALCF documentation that's on the website, which is also being updated in parallel to reflect that. But this is, of course, a study that goes over time, and things will be updated or changed as we see more uses and more use cases on the system. So with that being said, let's go talk about containers first. John touched on this a bit, but I want to emphasize this again because we've seen that a lot. A container is not a file. A container is not a directory. A container is a data set. It's a collection of files, collection of objects. It's like a mount point, a POSIX namespace, basically. You can have as many files as you want in your container. You will not get you will not get issues if you have a billion file in your container. If you have 1,000, 2,000, 10,000 or so containers on your pool, you will have problems, and you will get a message from somebody, me, Gordon, somebody will tell you you have a lot of containers in your pool. So please keep that in mind, that a container is a big data set that has multiple files and directories in it, but you're not supposed to have more than like tens of containers in your pool. Access permissions are through ACLs. So you can have multiple people, multiple members of the same project accessing the same pool or same container. There's some documentation on here on how to manage ACL access to dive into more too. Containers have types. So today on Aurora, on many use cases, 99% of containers are POSIX. Even DAOS is an object store, but still POSIX is most of the container types being used, and that's understandable because of the ease of use, and that's where everybody starts, basically. John will talk about some of the Python containers that we have with PyDAOS and PyTorch, which will be discussed after this presentation. And there's the HDF5 vol type, which, that's another container type, which also is not utilized much, but it's also another container type that's available today. So one thing, as you create an HDF5 file in your POSIX container, the container type is POSIX, it's not HDF5, right? The HDF5 container type is just when you are using the vol container, the vol DAOS connector. That's when it creates HDF5 typed container. So as I said, few containers as possible in your pool, tens, not thousands. Properties on containers. So before going into what the redundancy factor is, I want to quickly touch on what is a fault domain, and because you see me use that term a lot. A fault domain is a unit of failure, basically, an SSD, an engine, a server, a rack, basically. On Aurora, the fault domain is set to the server node. We can change that in the future, maybe to set it on a rack, basically, or something, nodes connected to a particular network switch. But basically today it's set to a server node which contains 2 engine and 32 targets. So, sorry, it's not SSDs, 32 targets, 16 SSD. So that's what defines a fault domain. So on the container, when you create a container, you have to set some properties. Unfortunately, today by default, that's not a conscious decision that we made. Well, for most pools that are currently created, when you create a container by default, it will create containers with 0 redundancy. So we recommend that you always set this RDFAC to 2. The redundancy factor, and I'll talk about what redundancy factor is. For newly created pools, we actually change it so that containers inherit the pool. So it depends on when your pool was created. It decides whether you want to set this property or not. But for now, to be safe, always add this property, this RDFAC2 property. And what does this mean? Is that it allows your container to survive 2 concurrent fault domain failures. And not just 2 failures, 2 concurrent failures. So if something happens on 2 server nodes, 1 or 2, rebuild will kick in. Your data will be rebuilt on 2 different fault domains, and you will survive. Your container will survive that failure without data loss. So and why 2, not 1? Sorry, because DAOS systems today, DAOS user, DAOS perf, and all those systems that are there are set to halt after 2 concurrent failure domains. So if you set it to 1 and we lose 2 server concurrently, rebuild will not be able to proceed and you will lose data. What happens if we lose if there's a network power outage, something that happens on some of the server, that's fine, because Aurora will stop. You will not be able to access your pool anymore in that case. If you lose more than 2, sorry, I keep pressing this. If you lose more than two concurrent fault domain, you will not be able to access your pool anymore. So until there's some sysadmin intervention to make sure that everything is back in place, and then you will be able to continue accessing your container. So long story short, if you don't want to experience data loss, your container must have RDFAC2 set when on container create. Checksums. So DAOS provides this feature to have end-to-end data integrity from the moment you give a buffer to DAOS to the moment it gets stored on the storage, and also on the back from when you read the data from storage back into your buffer. So again, unfortunately, this was it was not a conscious decision. It was disabled by default, but it should be enabled. The reason is that on Aurora, it is very important to enable this, is that we actually do see some data corruption happen over the network. It usually happens with memhooks, cache monitor. That's just some details. Using KDRAC2, don't see it much, but it could happen. So, and the cost of enabling end-to-end checksums is very minimal. So it is always advisable to also add this checksum property on. There are different checksum types supported, CRC, SHA, and I think a lot of the tests were done with CRC32. So that's the checksum type that you can use. And so when enabling checksum and end-to-end data protection, this will and end-to-end data integrity, this ensures that you will not experience any silent data corruption that can be introduced over the network. Does that make sense?
So if I'm just basically going back in, let's say I write an HDF5 variable and I have this enabled, and I then read that variable back in later in a subsequent restart or something, that will check the checksum?
Yes, it will do it automatically and over as it gets transferred from the client to the server to the client.
Thank you.
And it will fix it, right? If the read is corrupted, for instance, it will reconstruct from parity or read from another replica, right? To be clear. If it can, right?
Any other questions?
Will that checksum also if the say if the file isn't written to the destination server, would that reinitiate the transfer? Or
If the checksum fails when it is written?
yeah, so like I mean,
Yes,
say
yes.
with
Yeah.
POSIX, right? I write a file to the DAOS container, and then I mean basically will enabling the checksum sort of like
Yeah.
guarantee the file gets copied.
Correct. If let's say you are writing, let's say a file and one of your transfer experienced a checksum error, you don't have to do anything. It will retry that write if it saw a checksum error over the network, it will retry it automatically to get it into storage. So there's a retry built in when you experience checksum errors on write basically. On read, basically, you goes through some possible reconstruction if it experiences a checksum error on read. If you're doing redundancy, of course, read from a different replica, correct bad replica, and so on.
I see. And just one quick question. And so before you talked about the data node failures, like and so you said if two data nodes fail, then the data would not be reconstructible. So I mean, is that right? Or
So
No.
if two concurrent failures happen, data is constructible. One or two, it will automatically rebuild the data on two different fault domains. The problem happens is if you lose more than two. If you lose more than two at the same time, right? We're not talking about, if you lose, two, you rebuild, and then you lose two and you rebuild, that's fine. This is kind of, if you lose like four at the same time and all those, it depends what the failure is in that case. If like four different fault domains at the same time all have like somebody goes and pulls the SSD and smashes it from four nodes at the same time, then there is data loss in that case. But there are sometimes different issues, like a switch fails and four servers are not reachable anymore. That doesn't mean you lose data, because it just means that your pool will not be accessible until somebody re-enables that switch again, so the servers are accessible. So it depends the failures if you lose more than two. If you lose more than two, it depends what kind of failure you have, and that's when you say you can experience data loss or not, right?
If I might add, this is a complex topic, and usually it's sort of not presented to users. So standard systems like Lustre, GPFS use two parity. So that's what we're talking about here, is always using two parity. You can actually suffer probably hundreds of failures in parallel as long as they're in the right place, right?
Yeah.
But if they're in the wrong place and you have three failures, you can also be at risk. But this is true for any storage system. So it's just an explanation here that you can control this property, which is usually not typical of file systems. The administrator determines that, and it's set for the life of the file system. On DAOS, the user can choose some of their data protection schemes. And so we're strongly recommending that you always select two parity unless you really know what you're doing.
yeah, I see. So yeah, to guidance is turn on RD factor 2. So,
Yeah.
Correct. Yeah.
Yeah. On hindsight, maybe that's not a good topic for a slide, because it's a little advanced for other user. But that's typical. Yeah, as Kevin said, there's nothing special here or different from file systems, other than DAOS lets you say, I want to create a container with no redundancy at all, and I'm fine with it. But that's definitely not what we recommend and for any production scenario.
In hindsight, these defaults should be what they're going to be changed to in a little while. And then probably we wouldn't have even mentioned this because it's an advanced user topic. But we are in this window where the initial setup has aggressive settings, which it probably shouldn't have by default.
Okay, any more questions?
You said when the checksum on read fails, it will reconstruct the data. Is that reconstructed on persistent media, or is it just on the fly?
Yes. So Jean, correct me if I'm wrong, but yeah, go ahead.
No, go ahead. Sorry.
No, I would say is that for your read, it will try to reconstruct it and give you the correct data, right? But for the failed parity, Jean, maybe does it repair it there or?
No, I mean, so it's reconstructing on the client, Nathan, and then we bump the counter on the SSD on the server side. And so it depends when. So it's always on the client, and then it depends when the error is detected. If the error was on the SSD, we bump a counter on the SSD, but we don't fix it. And then there is a threshold, 5 or 10, I don't recall, where at some point we just exclude the SSD.
Ah, interesting. Okay, thanks.
So is there a way to validate all data in the container, like similar like fstk command?
There is, yes. There is I don't mention it here on the slide, but there is a DAOS fs command where you can do for POSIX container. There's a way to do DAOS fs check and DAOS fs repair if needed, to make sure that your data is consistent. And your namespace is consistent and viable and does not have any data loss. And you can do things like, if you can collect if for some reason you introduced orphan files or directories, you can collect them into a lost and found and things like that. So this is available. I haven't mentioned it today, but I can point.
Actually, my question was in regards not to structure like POSIX structure, but in general, like checksum.
Yeah, yes. There is also we're talking about POSIX here mostly, but yeah, there is a DAOS container check also for generic.
And there is also a checksum scrubber that is not enabled yet on Aurora, but is implemented, where basically on a regular basis on the engine, we will scan all the extent and verify the checksums, right? This was a feature that was part of the NRE for Aurora, but we haven't enabled it on the system. But we'll definitely discuss with the LCF to enable it eventually, to verify all the checksum proactively, right? And fix them for the one that failed.
Okay, let's move on. So in terms of how to tune objects, basically. So as I said, as we discussed before, DAOS is essentially an object store at the bottom, right? And the POSIX files and directories are built on top of this low-level API. So servers and things like that do not understand POSIX files and directories. They understand objects, basically. Objects can be created, with different, similar to files and things like that. Objects can be created with different redundancy level. You can have an object saying no redundancy, right? That's the non-production way of saying, I just want to see what the capability of my system is. There is some of the, redundancy mechanism is there are two in DAOS. There's replication, which is good for metadata or very small files, and erasure coding, which is good for generic file, medium or large files, basically. If not set by the user, DAOS automatically selects a default object class, what we call object class, which controls the striping and the redundancy for the scheme for objects, for files and directories in that container. So by default, it uses replication for directories and EC for files. And we can avoid looking at the first two columns here and just look at about the RF2, which what we recommend. RF2 is what you set on your container, the RDFAC2. So for files, it will use a 16 data 2 parity widely striped file. That's what X stands for, widely striped. And for directory, we use a replication scheme, 3-way replication, and just a single stripe. This works well for most use cases that we've seen, because most use cases have I don't want to say all, of course, there are many use cases where there are some tiny files, but most use cases have medium megabytes or more sized files and directories that aren't very fat. Like there's not like millions of files under a single directory, but there could be, right? But that's sort of the generic use case of things where things where things fall. The default for those can be changed in many ways. The first one where you can change the default is on container creation with file object class and directory object class setting when you're creating a POSIX container. The default settings are immutable. So once you create a container, you cannot change the default settings. But the objects inside the container can be created with a different object class than what is the default. There's different ways to do that, and we'll discuss that in a second. So, but as I said, the default settings work well if your files are large. I don't want to say gigabytes, megabytes or gigabytes is fine. And your directories are relatively lean, 10,000 entries. You don't have like a directory that contains 10,000, a million or a billion file under it directly. I'm not talking about subdirectories, right? Just the first level of the directory. If that's, relatively lean and, files are relatively large, this is fine. But so what does that mean basically when you set object class redundancy? What are the considerations when using replication or redundancy? So as I said, let's start with the replication. Replication is basically very simple, right? If 3-way replication, you write everything 3 times to 3 different fault domains. It's best for directories and small files, right? The performance hit is pretty simple, 3x, because you're writing three more times. The space, it might be a little more than 3x, of course, depending on because it's not always perfect linear scaling, but space-wise, it is 3x, right? It is not, replication is of course not recommended when your files are large, because you don't want to take that large space overhead when doing replication, and also the performance overhead. So for that, we have ratio coding, and the performance hit, it depends on how you access your data or how you write your data. For read, when you are reading in a ratio coded file, it's the same performance hit, whether if you're using redundancy or no redundancy. Read is the same. But for write, you will take like a 12 to 33% performance hit compared to when the peak bandwidth of the system, like when using no redundancy at all. And we talk about full stripe and partial stripe later, but basically you can expect your performance to range between 12% and 66%, depends on how you access your file. So having a conscious decision on how to access the file is important. And this comes where when we talked about these MPI IO settings before, it is when you use collective buffering, and this will take care of a lot of the performance optimization for you. If you don't use collective buffering and every process is writing small data or unaligned data and things like that, you will get into most probably into this partial stripe. The full stripe is when you're using collective buffering and you organize things well in aligned right according to the EC scheme, right? So getting this right can affect your performance, your write performance, basically. So that's what we were talking about the type of redundancy. Now, the striping basically, or sharding, what we call it in DAOS terms, but you might be more familiar with striping, is what comes after the X or the 1 on that case. So widely striped object means you are using all your server in your pool. Basically, it's best for if you want to get IO bandwidth, large IO bandwidth. So in most cases, like checkpoint restart application, or application, that write basically large files or read large files, you want the maximum bandwidth to be able to dump your checkpoint as fast as possible. You want to use widely striped objects, and that's what basically is by default set on the container to use widely striped object. But in some cases, especially like if you're using small files or if you're using something like file per process, and that's a common use case, file per process actually is not very efficient for DAOS, unlike other file system by default, right? File per process creates, if you have millions of processes and each process is doing file per process, your write IO will be fine. You will not experience any difference in IO performance if you're doing file per process or single shared file. The problem comes later when you're doing stat or ls, for example, on your directory that has a billion file at the same time, or trying to get the file size of a widely striped file and you have a million of those files, right? This is where the performance is a bit tricky because there's no client-side caching in user space at this time. If you use diffuse for these ls type of with caching enabled, that can help because that gets it once and it caches it, but it also has limitation for read-only workload. So take that into consideration. And I'll give some recommendation later on, the size of the files and what striping to use. So talking about, small striped object, this is on the other end of the spectrum, right? It limits the size and the bandwidth to the number of targets. Like this number that comes after the object class is how many targets you are striping to. So it is used, if you're writing very small small files, basically, or medium, like just on the order of megabytes or kilobyte sized files. In that case, you don't need a lot of bandwidth per file, right? You want more IOPS or more metadata performance, but because you have a lot of files, you get the bandwidth because the files themselves, it's not a setting for all files, it's per file, right? And that gives you the faster stat ls remove because in that case your stripes are small and not as large as there. So there's pros and cons to each. So how do you make the decision? This shows the recommendation on what is the best for the object class settings. Again, let's forget about RF0, RF1. Let's talk about RF2 here. So large files, single shared file, or maybe file per node, not file per process, right? What is recommended is use the default, basically 16 plus 2 GX. That's the default for files. And we're talking, when I say large files, we're talking about like hundreds of megabytes and larger, or gigabytes, basically. If you have very tiny files, tiny files, I'm talking about kilobytes and smaller, right? It's better to use RP3G1. So the question is, what if I'm using file per node on 4K node? It's use the default. That's fine. But again, so if your files are relatively large, right, and you don't have billions of files, the first one the default works fine. What you need to tune is that when you get into these other use cases where you have billions of very tiny files, for example, EC is not good even in that case. And we're talking about tiny files and we're talking about kilobytes. EC will be a replication at the end. So you can use EC16 P2G1, for example, but using RP3G1 in that case is faster. And now, you know, if you're doing something like file per process, but your files are large, right? You don't want just a single target. Use the 32 basically setting, and that is usually enough. So these are tunables. You know, it might require some experimentation, tuning, to see what's best. What I've seen is usually the default works well for most use cases. It's only when you have some out of the ordinary use case where you have to change things. So the default usually works well. That's
You have a question, Mohamad, from Tim. What if I am using file per node on 4,000 lattice nodes? Oh, sorry. Okay.
I answered that, but yeah, I answered that when I was talking. As I said, use the default in that case. Usually file per node is fine. That's like 4,000 files. That's pretty small. That's not large. So the default will work well. So how to change the object class at runtime after you create the container, basically. There are several ways you can do it. With the DFS API, the file create API lets you select the object class if you're using a DFS API, but most users are not. With MPI.io, there's a info hint that you can set Romeo DAOS object class. Usually you can set it either programmatically or through an environment variable. That lets you change it if you're using MPI.io. And finally, with the DAOS tool itself. So if you create a directory called D1, for example, you can do DAOS FS set at TR, the path to that directory, and set the object class basically there. So everything under that directory will now use this object class. So if you're familiar with Lustre, this is similar to LFS set stripe, for example. But the DAOS has its own tool to do that. Does that make sense? Any questions?
What about subdirectories? Do they inherit it from the parent?
Yes. So if you create D1/D2, D2 will use this setting. So if you want to change D2, you have to change it for D2 only, right? If you want to change.
But D2. Once it's created, can it be changed?
For directory, yes.
And what about all files and subjects below it? Will be changed as well or not?
You can change it. So if you create, like, let's say D1, D2. Let's say you yeah.
I just want to clarify, because things which are created, you don't change. Like their properties, like as the data layouts there, they're there.
Yeah, I can. Yeah, I was going to get into that. So let's say you create D1, D2, and D1 you create after you set this, you create D1, D2, and you create under D1 a file called file1. File1 will have this object class. You cannot change F1 anymore. F1 is set. That F1 as a layout for the file is set. What you can change is new files created under D1. So if you do call this again, but you set this to G1, for example, the new files under G1 will use G1. The old files will keep this scheme. You cannot change the layout of a file that's already created. But what you can change is the new settings for new files that are created. That makes sense?
Yes.
Okay. And that follows similarly to what Lustre provides with LFS. That's the same thing, basically. If you want to change an existing layout for an existing file, your only option is to copy that file into a different layout, basically. There's no way to change it in place. So for EC, we talked about full stripe versus partial stripe update. So this is getting into the weeds and advanced. So I don't want to touch on to get into details too much on this, and we can talk more offline and have a deeper dive if people want to in that case. But I just want to touch there are when doing EC, it's tricky to get all these settings right. As I said, usually the default works well if you're using the optimizations that we talked about with MPI.io, or your data is well behaved. But if it is not, you might need to have to play some with different settings when you're using erasure coding, like the object class, the cell size, the chunk size of DFS, like the striping of the DFS, and the application IO size on what you can do. So the ideal way, as I said, is we want to do full stripe IO, where IO size is a multiple of the DFS chunk size, and that's also a multiple of the EC cell size. Yeah, I don't want to get into too detail into the weeds into this, because the ideal first is that run your application first, see what performance you get. Nothing is unsupported. Basically, everything will be supported. Some things might perform very well, something might not perform as well, and this is where we can get more into tuning after the fact that you get your data in. So let's move on here. So this is now trying to summarize all the different properties I talked about. When you create a container, as you saw from John's earlier command, there's a lot of settings. The green items are by default, but these are things that you can play with, like the directory object class and the file object class. The red items are, as of today, are not default, but they will be in some future versions of DAOS and sometimes future pools that are created. So some of them have been added in as default, but it requires new pool to be created for you. But others will be in a later software version of DAOS that to be optimized things. But for consistency, I put the recommended container create command that everyone can use, and or tune for as a starting point. So we talked about changing the directory object class in the previous slide. If you want to change it after you create the container, if you want to change it for a directory, for example, and you set the object class to three-way replication. Now, if it's not possible for the application, like I say, I have an application that it's writing files, and they're all in the same directory. Some of the files are huge, and some of the files are tiny, and I cannot separate them into different directories. What do? The advice is to go with the larger file setting, because otherwise, if you go with a small file setting, you'll get space in some cases. So go with the large file settings. There will be a small performance hit for tiny files, but that's unavoidable in that case. If you can separate directories, files, large files, and tiny files, and in separate directories, you can use this mechanism, and that will be perfect. So MPI-IO settings, I think I've covered most of this when I talked about the MPI-IO driver. Basically, Diffuse, as I said, MPage will automatically use the DAOS ROM-IO driver if it detects it's a DAOS file system, but you still need to mount Diffuse with this launch Diffuse script, right? And other libraries on top using MPage, using MPI-IO, HFI, FINAT, CDF, ADIOS, all of those the same advice applies, the same as I explained when using MPI-IO. Some recommendation when using MPI-IO, the ADIO driver for DAOS is optimized for single shared file access, or basically, I don't want to say just single shared file, but not a large number of files, not file per process, basically. If you use, again, there was a question about file per node, using all Aurora nodes 10,000, that's fine. That's not a problem. The idea is, collective file open. It is optimized because it shares collective file. You can have optimization like collective file open. As long as you open the file collectively, IO access, whether independent or collective, is okay. The problem with millions or tens of millions of files being open at the same time independently, there's no collective sharing of the pool and container handle. We're not talking about file handle, the pool and the container handle. This can be very expensive to DAOS. So collective file open is important in this case, in this scenario. If that's not possible, if you have a million or or 10 million process over all Aurora compute nodes running at the same time, and you are using independent MPI IO access, it's actually better to use than the UFS driver versus the DAOS driver, and use the interception library in that case. And that will get you around the open of independent file open from millions of file at the same time. Enable Romeo collective buffering when doing collective IO. We talked about that. So yeah, let me pause here for a second before I go into some of the common troubleshooting issues. Can you talk a little about container chunk size default performance impact? Chunk size is basically the stripe size in Lustre terms, basically. So by default, that chunk size is set to 1 megabyte. So basically, if you're doing IO that's like doing like 1 megabyte IO, each IO will be optimized to go to a single single group, basically, or single target. So yeah, chunk size is basically how you stripe your data over different targets. Underneath the cover, it's basically under a different key, because DAOS is an object store, right? Everything in the first megabyte will go into one key, everything in the second megabyte will go to the second key, and so on. So in terms of performance, if you're doing doing a large IO, basically the default is fine. If you are trying to do something more, and where it comes more into play is when using the playing with EC schemes, and it's more like on a usually the default works fine, but or using this container command that I talked about later, setting the chunk size to 4 megabyte instead of the 1 megabyte. It's basically because we want larger things to go through the network. We want, instead of doing, if you set it to 1 megabyte, you are going to divide your IO into a smaller chunks if you're doing larger than 1 megabyte IO, right? If you're doing 4 megabyte and you do that for 4 megabyte IO, that's fine. How do we change the chunk size for large files? So you can either set it by default on DAOS container create. Actually, you can also do it per directory on, like, there is also a setting here called -- chunk size. So under a per directory, you can change it for those files to be created in the directory. If a file is already created, you cannot change the chunk size. But for newly created file, you can do it on per directory basis. Sorry, I should have added that also here, that you can change the chunk size for files under also using this tool as well.
The parameter on this DAOSFS setup, is this all class for directory settings or for files, or both?
Both. Unfortunately, today there is no. We will add that in the future, but there is not like containers. Directories use it for both now. We probably need to split it up, have one for file and one for directory, but for today it's for both.
Okay.
Okay, finally, talking about some troubleshooting, some issues that you can see when running with DAOS. And there are probably other things, but some of the most common things that you can see. If you get this error when you first, when you're trying to do, for example, DAOS pool list to see your pools, or DAOS any DAOS command when on the UAN or on the compute node, and you get this error from agent failed to connect to agent. What this usually means is that you have not done module use. Okay, this should be module load DAOS, but I was using the other cluster. So you just use module use soft. That's probably you're missing that part. And sometimes module load does not carry over in some environment or scripts, and you have to do it in your script also. So just make sure that this is done. Other errors you can get, And some of these errors, and you see those errors basically because DAOS is most of the what we talked about is user space IO, right? If you get an error from the network or the file system, you will see it yourself because it's all in user space, right? It will. It's not like Lustre, for example, or just using diffuse without interception or without if using diffuse without interception or not using MPI IO, you will not see those errors because they are hidden in diffuse log or the kernel. But when using user space IO, you will see sometimes errors from the storage that you are not accustomed to seeing. So these types of errors, if it come from the network, basically timeout or transport layer Mercury error, those are usually transfer errors. They are not fatal. They are basically saying your server target is busy. It can be, you are doing something naughty or somebody else is doing something naughty on the system, and and you get some timeout error from the server, and your IO is retried automatically by the client, but it logs an error in that case. So it's not fatal. It's an artifact of just doing user space IO. And the other artifact is that by default the setting but logs errors to STDR. There's a way to change that to not log to STDR, and I can provide that setting if needed. But sometimes you can say my IO doesn't progress anymore, and I keep getting those errors. That might be a sign that you need to ping somebody that maybe there is something on the system, or the system is, if you're running, for example, during maintenance, or the system in the rebuild state, you might get more of these errors than accustomed to. Some of the errors that are, really that are fatal to your app, basically, not fatal to DAOS itself. Like sometimes, and this is something we are working on, we will fix in the next release. Like sometimes, and we've seen that with particular application or access pattern, is that you get this libfabric error that you have no space left on device. Basically, you are hitting a network limitation on the number of buffers you're sending at the same time. This is common with some HDF5 NetCDF app, very few. And what basically you need to do to get around this issue is just enable collective buffering, and it usually resolves that problem. Next version of DAOS will actually do some optimization to avoid that problem. So, but that's something you can see in this scenario. And that's the last of my slide for this session.